Hello everyone. Today we are presenting our assignment on diabetes and its relationship with different health and lifestyle factors. My name is Karun and I'm here with my team members, Diwash and Suraj. Firstly, starting with objectives. The objectives of our report are threefold: to identify variables linked to diabetes prevalence and to apply statistical tests to assess associations, and also to derive actionable insights that can support public health. Jumping into data and variables. For this study, we used the 2015 behavioral risk factor surveillance system dataset, which contains response from over 441,000 individuals. From this dataset, we focus on diabetes status as the main outcome and explored related variables such as BMI, age, physical activity, smoking status, education, and general health. And along with that, we have methodology. And in terms of methodology, we first clean and pre-process the raw dataset in Jupyter Notebook and generated a defined version for an analysis. We then applied descriptive statistics such as mean, median, mode, variance, and standard deviation to summarize the data. For inferential testing, chi-square test were used to examine independence between categorical variables, and ANOVA was applied to compare average differences across groups. Python libraries such as Pandas, NumPy, Seaborn, Matplotlib, and SciPy supported our data management, statistical analysis, and visualization. And now I'd like to hand over to Divas.
In this section, I will discuss our exploratory data analysis and data visualization and introduce the research question with their hypothesis. The key variable we focused on were the diabetes group, BMI, education level, and smoking habits. We started with the distribution of diabetes status. In our data set, the variable diabetes 0, 1, 2 represents diabetes status, where 0 means non-diabetic, 1 means pre-diabetic, and 2 means diabetic. As shown in the chart here, uh, the majority of people are non-diabetic, followed by diabetic, then pre-diabetic. Next, we analyze BMI by diabetes prevalence. The visualization here shows that the people with diabetes generally have a higher average BMI compared to non-diabetic and pre-diabetes. We also examined the diabetic prevalence by education level. The results suggested that education may play a role with diabetes status varying across different educational categories. Finally, we looked at the diabetes prevalence by smoking habits, and here we observed some differences, indicating that smoking might be associated with higher diabetes prevalence. This exploratory data insights motivated our formal hypothesis testing, and our research question were, do people with different diabetes status have the same average BMI? For that, we set up a null hypothesis as the average BMI is same for all three groups, and the alternative hypothesis as for another question, we set up this question as, is there an association between education level and diabetes status? For this question, we set up a null hypothesis. Education and diabetes status are independent, whereas it has the alternative hypothesis as education and diabetes status are associated. For the next question, is smoking status affect diabetes prevalence or not? For this, we set up a null hypothesis. Smoking and diabetes status are independent, whereas its alternative hypothesis was smoking and diabetes status were associated. This hypothesis set the foundation for our statistical tests, which will be explained by our next friends.
Talking about hypothesis testing result, first for the ANOVA test comparing BMI across diabetes groups, we obtain an F statistics of 6,383.81 with a p-value close to 0. Significance level of 0.02, we reject the null hypothesis. This means that the average BMI is significantly different among people with no diabetes, pre-diabetes, and diabetes. Second, for the chi-square test between education level and diabetes status, the result was a chi-square value of 2853.70 with 10 degree of freedom. And the p-value was close to 0. We reject the null hypothesis and conclude the education level is associated with diabetes status. Finally, for the chi-square between smoking status and diabetes status, the chi-square value was 503.28 with 2 degree of freedom, and the p-value was also highly significant. We reject the null hypothesis here as well, meaning smoking is associated with diabetes status. And in conclusion, our results show the higher BMI, lower education level, and smoking are all strongly linked with diabetes. This finding suggests that both lifestyle factor and social backgrounds play an important role in diabetes risks. These highlight the importance of public health programmers that promoting healthy eating, physical activities, and awareness about smoking risks, as this can reduce the burden of diabetes in society. Thank you.